Greetings, everyone. Welcome to the ESGF webinar. Our speaker today is going to be Dr. Karl Taylor from Lawrence Livermore National Laboratory, and he's going to discuss the role of controlled vocabularies in CMIP. Karl, do you want to share your screen and begin?
Yes, let's see, so desktop probably work. Share. Allow Zoom to share your screen. Apparently I need to give Zoom, here we are. I guess we should have. Okay. Did that work? No. Now I do it again, maybe. This will work.
There we go.
Oh, do you want to record my screen, don't you? It says I have to open my settings. One more thing.
It should be working.
Okay, all right, fine. Then I will close this, go full screen. Are we good now?
That looks good.
All right, I'm in the wrong place here.
Yeah.
All right, sorry everyone. Well, thank you, Forrest and everybody, for inviting me to provide this overview of how we use CMIP6 or controlled vocabularies in CMIP6. I want to mention that before CMIP6, we used controlled vocabularies, but they weren't nearly as well organized. They weren't under version control and so on. But Paul Dirac has remedied that problem. Well, remedied that problem some 7 years ago, I guess. And so what I'm going to talk about really relies on the implementation that he put in place. So I'm going to try to answer these questions. Why do we need, why do we have controlled vocabularies? Why are they needed specifically by ESGF? For what purposes do they serve? And then I'm going to pose at the end a question about whether we might be able to have these controlled vocabularies evolve in time and be kind of have that reflected in ESG's catalog. So a controlled vocabulary really is used to populate what I'm calling data descriptors. So this is for CMIP6 specifically. We have about a dozen or so data descriptors defined for uniquely identifying data sets in CMIP6. The descriptor values are drawn from a list of permitted options. And of course, that list constitutes the controlled vocabulary. I'll give you a lot of examples in a minute, but I'm just trying to give you an overview. One of the constraints we placed on the CMIP6 controlled vocabularies is they should be interpretable both by humans and by machines. So they shouldn't be something like a UID that has a gibberish collection of characters, but rather should be a text that can be understood by a human. And since there's a limited number of these that are defined and included in the controlled vocabulary, machines can be taught basically to understand what they mean. They provide, CVs provide information in standardized form. That's the whole purpose. And they can be used, as I said, to describe data sets. And in particular, some of them in CMIP6 are used to uniquely identify data sets. So here's an example of a CMIP6 data descriptor and a CV. So we have something we define as a source ID, which is simply the model name. And it has permissible values. In the case of CMIP6, there's 131 models who have registered their names into a CV. I show some examples there. And then they are used, for example, to uniquely identify files. They're used in directory structures. They're used as search facets. And of course, the scientists who analyze the data rely on this information to tell them what model produced the data they're using. Just to give you an example from the search facet realm there, you see, I'm focusing on a particular model here, GFDL. And in the metagrade search, one of the facets is the source ID. That's the name of the data descriptor. And under it, it listed all the models, and the partial listing there that I've blown up indicates that GFDL is, of course, one of those. So the CDs, the CV values are used in lots of different ways and are fundamental, really, to manipulating data sets, managing data sets, allowing users to access data sets in CMIP6. Currently, we host these CVs on a GitHub site, and here's a partial listing. I give the GitHub address down there that's public. And this is a partial listing. You'll see we have the CMIP6 activity ID, experiment ID, frequency, and so on there. And when you click on one of them, for example, this is the realm CV. You'll see that it's really pretty simple in this case. It's a listing. It has the name of the data descriptor, realm, and that's followed then by basically key value pairs. And the key is the controlled vocabulary that populates that descriptor. You see aerosol, atmos, and so on. But then it's expanded to tell you exactly what it means: atmosphere instead of atmos, atmospheric chemistry instead of atmos chem, and so on. And then there's a bunch of version control information at the bottom of the file. So this is a simple example. Some of the other files are much more complex, and I'll give a couple examples of that in a minute. To give you an overview of what we have in the way of existing CMIP CVs, I've divided on the left the existing ones, and on the right some others that we might define in the future. And I won't really talk about the ones on the right, but on the left, we have some of the CVs control information that goes into a data descriptor, and then some of them go into kind of a different category, which I'll talk about in a minute. So we have the activities controlled vocabulary. This lists the different MIPs, really, CMIP, PMIP, CFMIP. Well, there's a whole, there's like dozens of them. I can't remember how many. Then we have the experiments, and there's a few hundred experiments defined for CMIP. So that's quite an elaborate CV. It not only includes the names of the experiments, but as you'll see in a minute, some other information about those experiments. There's the frequency, listing the various frequencies at which data gets reported. Grids, which are grid identifiers. There's institutions. Each of the institutions participating can register its name. Both has a very short acronym and a much longer description of that institution. There's the nominal resolution. I guess I won't go through all of these sources. I already showed you a partial listing of the source ID CD, and I also showed you the realms. Besides these kind of descriptive well, these CDs that contain descriptive information. We also have the definition of the DRS that's used for this project for CMIP6. And it gives, for example, the template for file names, the directory structure, the dataset identifiers, and so on. And then there's a CD that lists the recommended various options for a license and the modeling groups were supposed to take that license and insert it into their files. I'll have more to say about that later, because some of those licenses were subsequently changed, and we don't like to change the contents of a controlled vocabulary. Just to remind you that the CVs are relied on not only by ESGF, which is under this ESGF core software section, but also by other parts of the infrastructure. So at the bottom, you'll see we have the controlled vocabularies. They feed into not only the ESGF archive itself, where it's used in the cataloging and well, we'll talk about the different ways it's used, but it also goes into, for example, Seymour. Seymour draws on the information in the CVs to populate the information it stores as global attributes in netcdf files. It goes into the data request. It goes, the CVs feed into also the services shown, some of the services shown at the top there, things like the errata service, citation services, and the documentation of models and experiments. So the controlled vocabulary serve lots of different purposes. Oh, and I guess importantly, they allow these different components of the infrastructure to better communicate with one another. If ESGF wants to communicate what data set it would like to link, say, the documentation of a data set to a user, the documentation service needs to know what data set they're talking about. And of course, the controlled vocabulary allows it to pass information to the documentation service that it will understand and then be able to link to the proper documentation. Okay, again, to talk a little bit about the terminology, I've talked about a data descriptor, which is basically an attribute characterizing some aspect of a data set. These are needed. Well, the data set, the data descriptors that are needed or wanted or useful for a given project are defined by data managers and project leads. And you know, the data descriptors that are appropriate for CMIP may be different from those that are appropriate for OBSERMIPs. There are no instruments, for example, that in CMIP, but for observations, sometimes they like to identify what instrument actually made the measurement. So we'd need a data descriptor to do that. In any case, of course, the data descriptors are drawn, the values of the data descriptors are drawn from the CVs, and a CV then is a listing of acceptable data descriptor values. And the CV can be populated in a sense imposed by the data manager. And we've done that in CMIP, for example, for things like frequency. We only allow a certain set of frequencies to be reported. And so those are the frequencies that appear in the CV. On the other hand, CMIP is open to any modeling group that meets certain criteria and those modeling groups then can register their model into the CV. So that is not imposed, but basically people who participate register information. They not only register information about their model, but what institution is hosting that model, perhaps various characteristics of the model, what its native resolution is, for example, and so on. So these are kind of two different types of CVs. the ones where we kind of ahead of time decide what's allowed, and then those that are open-ended and extendable. I'll show 3 examples of a CV structure. This is kind of the simplest structure. It's just a list. We have the data set, or the data descriptor name, in this case, nominal resolution, and the allowed values then on the right, from 0.5 kilometer, 1 kilometer, up to 5,000 kilometers. And when you characterize a model, then by reporting its nominal resolution, you have to choose from this particular list. But some CVs are, as we saw already, a little bit more structured and in a hierarchical form. The activity ID, for example, is a simple dictionary with the name. Well, so the activity ID is the name of the data descriptor. The values it can assume are given as CF-MIP, Cortex, DA-MIP, for example. And then what those acronyms stand for are in the expanded form given as the value next to the key. But I want to stress that some of the information can be recorded in a CV in a form that's not really controlled at all. We can, for example, for an activity participation, we require it to be some sort of rather short acronym. The institution ID has to be a rather short, again, and that in this case, it has to be drawn from the institution controlled vocabulary. That tells you which institution is associated with this source ID. But then there's an extended label that contains information that's not controlled at all, and its format is also reasonably open. You notice that the actual source ID value, E3SM-2-0, these values cannot contain periods or spaces, because this particular data descriptor is used in file names, for example, where some systems don't like you to have blanks or periods. But in the label extended, you can write it the way you would normally perhaps identify your model. Now, I want to stress that not only are the CVs recording the potential values of a data descriptor, but the actual values that apply to a data set are recorded typically as global attributes in the file itself. And they may also appear in file names and directory structures. So the user has to decide which value of the data descriptor is appropriate for a given data set, and then that's what's supposed to appear in the file. But in the global attributes, there may also be recorded additional information that is controlled vocabulary. And as an example, I'll note that in the file, you will report what the name of the experiment is that the data comes from, but you'll also report the name of the parent experiment, and maybe and also the name of the activity and the MIP area that it comes from. But it turns out that for the experiments in CMIP6, the parent is designated, or it's determined really, by what experiment. The historical run is always spawned from the control run. And so the parent experiment is the control run. And when you write that into a file, you better get that right. It has to be consistent with what is specified by the experiment. And if you make a mistake, and instead of writing control run, you write something else like, say you wrote control run, and the actual parent experiment name is PI control. If you put control there, then there would be a mismatch between the actual parent experiment name and what you've recorded. And we'd like to be able to, this can lead to inconsistencies then between what you've put into your file and what is in the controlled vocabulary. And we'd like to be able to correct that. And I'll talk about that a little more in a minute. Another example is a license. In CMIP 6, the modeling groups wrote into each file what the license conditions were. These were Creative Commons licenses of various varieties, but sometimes the modeling group subsequently wanted to relax their license. And so we decided that we would put the licenses as one of the attributes of the source itself into the CV and record it there. And there we could modify the license if a modeling group decided to change it. Whereas if they'd written 1,000 files, it'd be much more difficult to modify the license that appeared as a global attribute in the file. So in this case, you can see that the true license that applies to a data set is recorded in the CV, and it may sometimes be at odds with what has been recorded as a global attribute. There are constraints on controlled vocabularies that we place. We normally would not want to modify a CV value once it's in place, but we can add values, as I said. For example, sources, we wouldn't want to change the name of the source that's already in the CV, but if an additional source, a different model wanted to contribute to CMIP, then it could be added to the CV. Okay, and as I said, when a data descriptor, sometimes the data descriptor recorded as a global attribute differs from what's been specified within a CV. And in this case, the CV is assumed to be correct, but with the caveat that if actually if a data descriptor that appears as a global attribute or in a file name is incorrect, that has to be corrected. You can't rely on the CV to tell you what the true value is. It actually has to be corrected by rewriting the data or renaming the file. So what does that ESG need? It needs, for example, access to the descriptor values. So depending on the project, the CVs may be hosted in different ways. For the WCRP projects like OBS for MIPS and Input for MIPS and CMIP, we try to structure our CVs similarly, but they're not identical. So we will have to tell ESG where it can find the controlled vocabulary values it needs to populate its catalog and to use in its search. And also, I want to say that the data descriptors are kind of defined in different ways, or the constraints on them may differ from one data descriptor to another. As I've noted, there's some data descriptors that can be basically uncontrolled free text, but most appear in some kind of a controlled vocabulary. So the simple case, with recognized values, but sometimes a data descriptor might be kind of a string that has to be consistent with a certain format, but the content can be up to the user to a certain extent. So an example of that is in CMIP 6, we had something called a variant ID, which was in the form, we called it the RIPF indicator. It was pretty hard for people to understand what this meant, but it had to be of the form of R followed by an integer, I followed by an integer, P followed by an integer, and F followed by an integer. So for example, R1, I2, P3, P, F2 would be an RIPF variant ID. So it had to follow a certain template, but the values of the integers were up to the user. And sometimes there are constraints on the data descriptor because one data descriptor is really implied by another. For example, once you tell me the variable ID of a CMIP6 variable, something like TAS, which stands for surface air temperature, it has an implied standard name, which is basically air temperature. And so standard name is one of the, has a controlled vocabulary given by the CF standard name vocabulary, but the value of that name for a given variable ID is determined. So we can check if we're careful, we can check, or if we have the software in place to do this, we can check whether the standard name is consistent with a variable ID. There are lots of, one of the values, of course, of the CV is that ESG can check for consistencies before it publishes data. We can make sure that, for example, that any data descriptor defined in a file actually appears in the CV. We can check that the file names are consistent with the templates needed and also the data descriptor values. We can check whether the CV serves as, well, sometimes the CV, as I said, serves as a reference, and we just copy it into the global attribute. And if it's been copied incorrectly, we can trap that. Perhaps, but these kinds of checks will be project dependent. They will differ for OBS for MIPS than they would for CMIP, for example. So it might be that ESGF is not responsible for doing this, but relies on the group contributing data sets, or the project that contributes to data sets, to provide it with some sort of a checker that it can put into its pre-publication pipeline. And we did this in CMIP6. We had a code called prepare that would check a lot of the metadata that was in the file before the data set could get published. So one of the ways that ESG relies on CVs is to populate its catalog and its search facets. So currently, for each different project, but the point is that these catalogs and these collection of search facets may differ from one project to another. So one of the things is we have to communicate to ESG what should be in the catalog, what should be in the search facets. Once that's decided, a lot of the search is performed based on what appears then in the catalog. And what appears in the catalog is placed there primarily at the time of publication. But there are a few things that get added later on or can be modified after publication. We have something that indicates the version of a data set that can be initially, well, when it's published, it's the latest version, but later on it could be deprecated, for example. Also, we indicate whether a data set is a replica or is the original copy of the data set. So these things appear in the controlled vocabulary, in the catalog, and they can change post publication of the data. And it would be useful to be able to also change some of the metadata that we put into the catalog at the time of publication after it is published. So what I'm thinking of as, again, we had in the catalog what the license is. Well, there's lots of things that could get recorded initially incorrectly in the catalog. And if that information is not used as to uniquely identify a data set, then there's no harm in changing the catalog to correct it. And that would be a useful capability of in ESG. One of the things I wanted to introduce is the idea of collections of data. This is something that wasn't in CMIP 6 that I think would be useful to provide for CMIP in the future. And in particular, what I'm thinking of here is the idea of a collection of data, and that these collections could evolve over time as data sets were added, but they would help us filter searches. And I'm going to kind of skip through this wordy diagram and go to this, which explains a little bit the concept of these collections. We distinguish between a host collection of, a collection can host a set of its so-called hosted experiments. For example, PMIP is responsible for a certain set of experiments there on the left. The last glacial maximum experiment, the mid-Holocene, and so on. But PMIP also relies on one of the CMIP experiments itself, the PI control run. So that's what I would call an adopted experiment into a collection. CMIP is at the top there, and it hosts AMIP, the DEC runs, the PI control run, the historical run. And these experiments are really used by many of the MIPs that participate. And so they could be incorporated into their own collections. And then we can also define a collection of kind of a super collection of experiments, what we might call the CMIP experiments. And that's shown in the middle at the bottom there. Basically, those are the union of experiments from the various MIPs plus CMIP itself. But importantly, if you look again at the PMIP example on the left, PMIP also authorized certain experiments that weren't in some way formally approved by the CMIP panel, but were ancillary to the main CMIP experiments. I listed those at the bottom there. Those weren't considered to be part of CMIP, but they were of interest to people, in the paleoclimate community who wanted to analyze PMIP experiments. And so it would be nice to be able to host those additional experiments as part of the PMIP collection. And even though they didn't feed into that collection and the large collection of adopted experiments shown that we called the CMIP activity experiments, the CMIP 6 collection. So I'm hoping that maybe something like this can be instituted. It does require a bit more management of and control over the catalog than we have at present. The virtues, just to reiterate, the virtues of a collection concept is that we can group together data sets in a way that they weren't originally grouped. We can form a new collection from existing experiments and make that then more as a package more easily accessible to users. As we can make collections one of the search facets, for example, so that we can expose a smaller collection than the 200 odd experiments to users who have an interest in them. It also provides flexibility and, well, as I said, user access, and we would need to enable the capability to regroup data sets after publication. So to summarize, why do we have these controlled vocabularies? Well, it enables the infrastructure components to uniquely identify data sets and interact using a common set of terms. And it provides users with well-defined descriptors of the data sets that they're trying to analyze, so that these things are unambiguously defined. What we need for ESG are about a dozen of recognized data descriptor values that can be used for search facets, data set identifiers, and so on. And what purposes do they serve? Well, they provide precisely and unambiguously define the key characteristics of data sets. They enable us to do more comprehensive quality assurance as part of the publication pipeline. And I suggested at the end that there are some extensions to ESGF that might be made so that we can more easily alter the information in the catalog to be consistent with if things are corrected in a CV and don't need to actually be corrected in the file itself. And I'll stop there. Thank you very much.